Good morning, sir.
Yes, good morning. Good morning, everyone. So we are in the type 5. Probably this one is a third and last session on the type 5 here. That is a change of variable. One of the standard transformation that we see in the change of variable, that is a transformation from Cartesian to polar. Transformation from Cartesian to polar. Remember, whenever the integrand contains the term of x square plus y square, or the boundary of a region of integration is a circle, it's better to transform that in a polar. Okay, it's better to transform that double integral in a polar. So we have to evaluate this double integral first by changing to the polar coordinate. So before that, I will ask 101, tell me what are the boundaries of the region of integration from the limit? Yes, 101. Okay, anyone who knows the answer, raise your hand. Okay, 143. Good. Yes, tell me, Sufyan.
So 0 to infinity.
Yes, so both limits are 0 to infinity. So we have the limits for x as a 0, x infinity, y as a 0, and y as infinity. So tell me what x equal to 0 represents. What x equal to 0?
Y-axis.
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 Correct. Good. So first one, x is equal to 0 is a y-axis here. So I will say this is x equal to 0. Then y equal to 0, x-axis.
X-axis.
Correct. So this is y equal to 0. Then x is infinity and y is infinity. That means it is a very large number. So what will be the region of integration?
First quadrant.
First quadrant.
Very
First
good.
quadrant, sir.
Okay, so that's a good observation. So here, the region of integration is the first quadrant, but it is unbounded. Actually, this is unbounded region. Only, yes, their boundaries are like x0 and y0. That is positive, that is x-axis and y-axis there. That one. That's the region of integration. The question itself, it is written, change to the polar. So we are going to transform the double integral into polar. So what are the transformation?
Sir, x is equals to r.
X is r cos theta.
R cos theta.
R cos theta and y is equals to r.
Y is r sin theta.
Theta. And what is the value of dx dy?
R dr d theta.
Correct. R dr d theta. So the integral I will become a double integration now. What is x square plus y square with this coordinate?
Sir, r square.
R square.
R minus r square.
So this is our double integral. Is that? What will be the position of a strip now? Position of a strip.
Radial. Yes, sir.
Radial is a correct answer. That is along like a hand of the clock. It's a radial direction. What will be the limits of r?
0 to
infinity.
0 to infinity. Okay, good. So that about the limits of r, and what about theta now?
0 to pi by 2.
0 to pi by 2.
Pi by 2. So this
0
is
to
the
pi by
line.
2.
This is a line where theta is a 0,
Sir,
and this is a line where theta is a pi by 2.
There is a black line. How did we come to know about this?
This is the radial direction. You can draw it anywhere, na? This is the strip. This is the position of a strip. Just in Cartesian, we take a vertical strip or horizontal strip. Here we take a radial strip.
Yes.
Okay. So the limit of r is a 0 to infinity. Theta is a 0 to pi by 2. And now the task is left to integrate it. Okay. Our aim is to integrate this one. Now, for integration, let I ask 125, 125. Yes, 149.
Yes, sir.
Integrate this.
So we will put r square equals to t.
Very good. This is the substitution that,
Yes, sir,
that
substitution.
works. Let r square is a t.
Yes, sir. So
Then
r dr will be d theta by 2.
okay, dt by 2. Okay, correct.
dt by 2, yeah.
Okay. So the integration of e raised to minus t will come because you are replacing this one by t, na? So e
Yes,
raised
sir.
to minus t dt. So, or you can do substitute here also, or you can
Yes,
do it
sir.
in rough also, like
Yes,
e
sir.
raised to minus t to dt by 2. So this one is 1 by 2 or minus 1 by 2 e raised to
Minus
minus
t.
t. Now
Yes,
I
sir.
am going to resubstitute the value of t and tell me what will happen. What is the integration then?
0
Minus 1 by 2
e raised to minus
minus,
t.
not t now, I'm in the
R
same
square.
domain, r square.
Okay,
So
direct.
resubstituted, okay,
Okay, sir. Okay.
and d theta. This one is only left
Outer limits will be 0 to pi by 2, no?
0 to pi by 2, correct. Outer limits are 0 to pi by 2, good. So that about the outer limit, and inner limits 0 to infinity as it is. Now
Yes,
what is
sir.
the value of e raised to minus infinity?
So 0.
0, and e raised to 0?
So 1.
1. So the next step, I will write it here. The value of integral will come 0 to pi by 2. This is e raised to minus infinity 0, and that minus minus is plus 1 by 2 d theta. So 1 by 2 as it is, integration of d theta is a theta, limits 0 to pi by 2. So the value of integral is coming pi by 4. That's the end of the first part of a question. If you have any doubt, you can ask anyone.
Sir,
Yes.
so why pi by 2, sir? Can you explain that part?
Where is the region? Region is in first quadrant, is it?
Yes, sir.
So what is the theta in the first quadrant? From 0 to
Theta.
pi by 2, obviously.
Okay, sir.
So, and maximum theta can be 0 to pi, 0 to 2 pi. Okay, that is a complete all four quadrant. So right now it
Sir,
is enough to drag that strip. Actually, the strip is we are rotating. The strip initially we keep at theta equal to 0 here, and then we are rotate that strip up to pi by 2 like this. Then it covers the region.
We can
sir,
also
if it is
substitute
in the
x and
second
y.
quadrant, sir,
Pardon?
if it is in the second quadrant, sir,
If it is in second quadrant, pi by 2 to 2 pi, then you know the second quadrant start with the theta equal to pi by 2 and ends at theta equal to pi, no?
yes, sir, yes, sir.
So it's straightforward.
Okay.
So the value of double integral by changing to the polar we got as the pi by 4. Remember, whenever we transform this double integral from Cartesian to polar, the calculation becomes simple, and that is only the purpose of transformation. Okay, why we are transforming? Because to simplify the problem. But in the question it is always given, so whenever it is given compulsory you have to do it. Whenever it's not given, then it becomes your choice whether you have to transform or not. Any doubt?
Sir, in the substitution where you did r square is equal to t, so
Correct.
there was dt divided by 2 as well, right?
Yes, here written na 2 upon 2.
But so that is integration of e to the power minus t. Okay,
Integration
sir.
of e raised to minus t is a minus e raised to minus t. So that is
Yes,
minus
sir. Yes,
7
sir. Got it.
like this. Okay, but the question is still not complete. There is one more part. Hence, show that integration 0 to infinity e raised to minus x square dx is the root pi by 2. Okay, this is one more part that is asked in the question. So can I move to the second part now?
Sir,
Yes.
hello. So can you again explain me that dx dy is equals to r dr d theta? It is by Jacobian.
Pardon?
So can you again explain me how that dx dy is equals to r dr d
This
theta?
is by the Jacobian formula.
Okay,
Dx dy
okay,
is a
got it.
Jacobian of xy with r theta. If you calculate Jacobian, you get r there.
Okay,
Now you
sir.
have to
Thank
remember
you.
directly. For standard
Yes, sir.
transformation, don't calculate. Remember dx dy is r dr d theta. If you want, yes, you find out Jacobian of xy with r theta there. Okay.
Okay, sir.
So we've seen that at the beginning only. That is a Jacobian of xy. That is a determinant dou x by dou r, dou x by dou theta, dou y by dou r, and dou y by dou theta. If you calculate, that value is coming r here. Just a minute. Just a minute. I think I'm switching to the network. Yes, 149 says, can we substitute the values of x and y to find the limits of theta? Actually, that's not required, Sahitya, because straightforward, you have to see the region is in which quadrant, and that gives you the limit for theta. Clear? Generally, the theta limits, you can get it by observation only. By x and y also you can calculate, but that can become more complicated. Now the second part. To start the second part, we have this integral. Just we completed the integral value, which is a double integral, 0 to infinity e raised to minus of x square plus y square dx dy is pi by 4. Yes, anyone? What is the way to proceed to get the required answer? 160, 160. 120.
I want to try.
Okay, 126, yes.
Sir, e to the power minus x square into e to the power minus y square can be written.
Correct. So that is the main trick. So if you got this step, the first step, which is just the property of indices, the base is the same. So you can separate the power e raised to minus x square into e raised to minus y square dx dy is a pi by 4. That about step number 4, because we have to prove this. Okay. Now, whenever fx into fy is there and the limits are constant, you can separate these integrals. So I can write the first integral as e raised to minus x square dx into 0 to infinity e raised to minus y square dy as a pi by 4. Okay. Any doubt? So this can be done only when the limits are constant. The limits are constant and function is a product. Function is product. That means you can do it separately. Okay. Now the last step is important. Yes, to get the required answer, you'll observe this integral and this integral is the same. Only the inner variable is a different. Okay. So this is known as a dummy variable. This is known as a dummy variable. For example, if you have the doubt, let I show you what is the dummy variable. If you evaluate integration 0 to 1 x dx, can anyone tell me what is the answer? Integral 0 to 1 x dx.
1 by
1 by 2.
1 by 2.
1 by 2.
Okay. If I ask answer integration 0 to 1 y dy, what will be the answer?
1 by 2.
1 by 2. 1 by 2 only.
Okay.
1 by 2.
So you'll observe the value of integral not depends on the inner variable, it depends on the limit mainly. So same thing is here, the limits are same, the variable is changed. That means you can replace y by x also here. You can replace y by x and that is a dummy variable, provided there is a separate integral that you can do it. You cannot replace y by x in the original integral, in the original double integral. When separate integrals are there, then only you can do it, and that is a dummy integral. So I can write it, this integration 0 to infinity e raised to minus x square dx into integration 0 to infinity e raised to minus x square dx is a pi by 4. Now this bracket into bracket, it becomes a bracket square, and if you take a square root, you get this as answer.
So,
Yes.
so can we write that directly, or we should write something in the bracket?
You can write it directly also, bracket square and
Okay,
then,
so okay.
So this is just this one is just given for understanding why I can replace y by x here directly. Okay. So next step is the required answer. Then taking square root on both sides, you have the answer. If anyone have a doubt, yes, you can ask.
Sir, sir, in case of the dummy variable that you took in the last step, sir.
Correct.
Sir, for that, sir, you have taken that dy as dx only because there are constants, no?
No, because what we done actually we replace y by x. If y is x, dy is a dx, na? If we take y equal to x, then dy is a dx.
Yes, sir.
This only the thing that is this can be done because they are separate integral. This is individual separate one integral. Okay. Now in this integral you can replace y by anything, y by z, y by w, y by anything. That's all.
Sir, if only if the values, the limits are same, only then only we'll be doing, no?
No, not necessary same. It can be anything. Now if it is here 0 to 5 and e raised to y dy is there, you can replace 0 to 5 e raised to x dx also, na?
Okay, sir. But they should be individual, no? Like this one.
Individual is the correct answer. That should be the individual integral. Then only you can replace, not combined.
Yes, sir. Thank you, sir.
Any doubt there? No. So this one is one of the solved example from the book. So solution you can see in the book also. I will show you a solved example. Uh, 107 is asking why we drawn the region in the first quadrant. Obviously, x is 0, y is a 0, and then x is infinity, y is infinity. 107, tell me. So which one is the place then where x is a 0 to infinity and y is a 0 to infinity? 107, are you there?
Okay, sir. Yes, sir. Yes, sir.
So x is a 0 means y-axis to infinity, and then y is a 0, that is x-axis to infinity, that is positive quadrant only. You should know
Yes, sir. Yes.
limits mainly
Yes, sir.
decide
Yes,
the
sir.
region. Okay.
Yes, sir. Yes, sir.
So this
Thank you,
is
sir.
the solution that given in the book, similar what we done. So I'll not go in there. So now question number 20 is not a new question. What is the difference in previous and this question?
Here we don't need to prove
Yeah,
that
correct. There is no
under root
second part
5
over
by
here.
2.
But I will tell you the funny thing that many of the students, if this question asked in the exam, if this question comes in exam, many of the students blindly complete the first part as well as they prove this also. Okay, they also prove this one and they highlight again. So many of the students don't have the habit of reading the entire question, just like they by heart the solutions and they complete it. So you should first of all read a question carefully. You should understand what is given and what we have to prove, and do that much only. Don't do unwanted calculation. It will waste your time only. Okay. So only the first part we have to do it, and that is we already completed. So this example is finished already, so no need to do it. So second example is on the screen now here. Evaluate a double integration xy dx dy where the region R is a quadrant of the circle x square plus y square equal to a square, where x is positive, y is a positive. So 107, you only tell me what is the region of integration.
Sir, it will be positive squad. So it will be some positive quadrant. The first quadrant, sir.
First quadrant, entire first quadrant.
No, sir. First of all, sir, we will draw a circle of radius A.
Okay, if you draw a circle of radius A like this.
Yes, sir. Whose center is at origin.
Okay. The radius is A. Next, what is the region of integration then? Yes, 107. What will be the region of integration?
Wait, sir.
It is given na, the quadrant of a circle. The quadrant of a circle where x is greater than 0, y is greater than 0, where it exists.
Yes, sir. In the first quadrant, sir.
First quadrant, that part of a circle.
Yes,
that's
sir.
all only.
Yes.
This is the region. The region is in the first quadrant because x is positive and y is positive. Okay, that's happens only in the positive quadrant, first quadrant there. So whenever the boundary is a circular for the region of integration, we should transform it to a, we should transform the double integral to a
Polar form.
Okay, so that is a better choice for a simplified calculation. What is the value of x in polar?
R cos theta.
So x is r cos theta. What is y?
R sin theta.
Sin
And
theta.
dx dy?
R dr theta.
Limits of r now. Limits of r. Strip is along a radian. What about theta?
0 to pi by 2.
0 to pi by 2.
Correct.
Pi by 2. Sir.
0 to pi by 2.
Good. That's one. Because again a positive quadrant. That's one. See, the calculation becomes so simple when we transform that in a polar, because the region of integration of the boundary as a circle. Okay, even though it is not mentioned anywhere, do it in polar. We are doing in polar. By chance someone does in Cartesian, that is also correct. I am not saying that calculation, if you do it in Cartesian, that is wrong. That is not wrong, but best solution is in polar form because it becomes simple. Now let me integrate this. So 0 to pi by 2 as it is. What's the integration of r? How many r's are there? 1, 2, 3.
R to the power 4 by
R
4.
raised to 4 by 4.
R raised to 4 upon 4 is the correct integration. Limit is a 0 to a, and we're left with sine theta, cos theta, d theta. So that a raised to 4 by 4 is as it is. And how to integrate this now? Sine theta, cos theta.
Multiplying dividing by 2.
2 and sine 2 theta.
Multiply and divide by 2.
Yes, good. One of the way is multiply and divide by 2, and when you multiply and divide by 2, it becomes sine 2 theta, and integration of sine 2 theta will be minus cos 2 theta upon 2. That is one of the way. The other way, yes, is also there. If I put sine theta as a t and cos theta d theta as a dt, the integration of t dt become a t square by 2. That means I will take sine square theta by 2. That's a direct integration because I replace sine theta as a t. The limits become a 0 to pi by 2. Both way it is correct. You can do it in any of the way. Now if I replace upper limit, what is sine pi by 2?
1.
1. And sine 0?
0.
That's 1. So we got the answer a raised to 4 by 8. That is the end of the question. A raised to 4 by 8 is the answer. If any doubt is there, you can ask. I replace sine theta by t, cos theta d theta as a dt, then sine theta, integration of t dt is a t square by 2. So directly written sine square theta upon 2. If you do in Cartesian form, you should get the same answer. If you are doing the different answer, definitely you made a calculation mistakes. So choice is yours. If you want, do a Cartesian, but don't do the mistakes then. Okay.
Sir, in the question, it will be given that we have to do with Cartesian or in polar.
No, so in some of the question it will be given, do it in polar only. Some example of Cartesian form, you can do it in polar by your observation. Okay. So polar form is sometimes given compulsory, but Cartesian form never says as a compulsory. Whenever the question in Cartesian form, you can transform it in polar whenever you require. Requirement means the boundary should be a circular. Boundary of integration should be a circle. Then only it is better to transform in polar. Otherwise, no use. Don't transform every example in a polar. It is of no benefit then.
Sir, when can we change in polar?
Yes, we change in the polar.
Okay, sir, understood.
So excuse me, sir, I have a doubt. So I always get confused when inequality is given. So sir, what if in this question it will be x is less than equal to 0 and y is less than equal to 0? I mean the signs are reversed.
Then which quadrant? You should tell me when x is a negative and y is negative, which quadrant?
So third.
Yes, that's one only. So you have the answer with you only.
Okay.
So you should think only X positive, Y positive, which quadrant, X positive, Y negative, which quadrant, that way.
Okay.
So generally everything is given in first quadrant only. Majority of the examples we have only in the first quadrant.
Sir, there the range of theta will be pi to 3 pi by 2, right?
Yes, correct. If it is in third quadrant. Okay. So next question is here. Evaluate this double integral dx dy where the region is bounded by x square plus y square equal to a square and x square plus y square equal to b square where a is less than b. Okay. If not given, you should assume that let a is less than b. X-axis and y-axis. Okay, 150.
Yes, sir.
Tell me what is x square plus y square equal to a square?
So it will be a circle of radius A
A center.
as at origin.
Correct. So suppose this is my first circle. Okay, radius A. Okay, next.
And second circle of radius B.
Okay, and that is because A is less than B, we should draw
Yes,
like
sir.
this. The region is in
Yes.
between them, na? So
Yes, sir.
So this is the region. Okay. Now the boundaries are again a circle, is that? The boundaries of region are circle, na?
Yes, sir.
So better to transform it in
Polar form.
Now tell me the limits of R then.
A to B.
Correct. This R is equal to A and this R is equal to B. Good, very good. So I will write this double integral dx dy is R dr d theta. Limits of R just you told me that is A to B. Or what about theta?
0 to 2 pi.
0 to 2 pi.
0 to
Correct.
2 pi.
Because the region exists in all four quadrant 1, 2, 3, 4. So it is a 0 to 2 pi. That's one. See, the calculation becomes a simple. And I will tell you one more thing. This is the formula, whatever we are doing, double integral dx dy. This is the formula of area of a region. Indirectly, we are calculating the area of a shaded region, and that we can easily get by subtracting the areas. So pi b square is the area of outer circle, pi a square from the inner circle. So final answer will be pi b square minus pi a square. Okay, so but here we have to prove it mathematically. So we are doing this mathematical calculation, that is area of that shaded region. So 131 integrate with R. No. 165.
Sir, R square by 2.
Okay, that's R square by
Yes,
2 and
sir.
the limits.
B to
A to B.
upper limit is B and lower limit is A.
So it is a b square minus a square upon 2. And integration of d theta is a theta. You got the required answer pi b square minus a square. That's one. Got it? Is there any doubt, anyone?
No,
No,
sir.
sir.
Okay, so 165 said he done it in the Cartesian form. Yes, if you do it in the Cartesian form, that's no issue. I don't have any problem, but your answer should come same and you should be mathematically correct. Okay, so choice is yours. You can do it in either Cartesian or polar, but I will suggest again and again that whenever the boundary of the region of integration is a circle, part of a circle, better to transform in a polar. Okay, your calculation becomes really a simple. I will not tell you anything in a Cartesian because it's complicated already. I told you, because that you should follow the instruction. Otherwise, if you want to use your brain, you should use that and you find your limits then. Okay, because limits become complicated. You will observe clearly here like this. If you do in Cartesian, you take a vertical strip. First of all, you have to take 4 times. It is a 4 times double integral, 4 into double integral dy dx, vertical strip vertical. Then you have to see here y is equal to root of a square minus x square to y is equal to root of b square minus x square, that way. So root of a square minus x square to root of b square minus x square, and limits of, obviously the x is 0, not 0 to a, now a to b, because this is x equal to a to x equal to b. So outer limits are a to b there. So this is really complicated as compared to the polar. So choice is yours. You can do it in polar or Cartesian.
So, sir, we have to do in polar when it is circle, one case, and the other cases?
Pardon?
Sir, usually we convert to polar form when it is when circle is given.
Correct. Okay, I will tell you the two things. When the questions are with transform to the polar and evaluate, compulsory how to transform it. Otherwise, when the boundary is a circle of region of integration, you can transform to the polar. Okay, so these are the two ways to identify the problem. Now the next question is on the screen here. Evaluate double integration y dx dy, where actually this capital R is a region in the first quadrant bounded by ellipse. Okay, so there are small mistakes are there like this. So this should be the capital R, and this is double integration over that region R. So we have to do the double integration y dx dy on the region R, where R is the region of the first quadrant of an ellipse. Now this is the last type that we have in change of variable. Whenever we do some double integration on an ellipse, again I told you that there is a better to use a special transformation of ellipse. So 110, can you tell me that transformation 110? Transformation of ellipse. 148.
Sir,
148.
yes, sir.
Yes, tell me the transformation of ellipse. Standard transformation. We seen in the last session, last of last, I think.
Ellipse. So
Okay.
x will be equal to
106.
AR cos
X equal to?
AR cos
AR
theta.
Correct. X is equal to AR cos theta.
y is
Y
equal to
is
AR
equal to BR sin theta, and dx dy
ABR DR D theta.
ABR.
ABR dr d theta. Now remember, these are the special transformation made only for the ellipse. Why they are important for the ellipse? Because this transformation always deform the ellipse to the circle. They convert any ellipse to the circle of radius 1. How we can check it now? Let me replace these values of x and y in this equation of ellipse. If you replace the values of x and y in the ellipse, you will observe this become a square r square cos square theta upon a square. So a square x square gets cancelled. You get r square cos square theta only. Similarly, here you get r square sin square theta. Again, r square come common. Cos square plus sin square is 1. So you get r square equal to 1. So finally, you are going to get this equation which is converted to r is equal to 1. R equal to 1. Is it clear? This is the Cartesian equation and this is the polar equation by the special transformation. These are not simple transformation. Remember, if you replace x by r cos theta and y by r sin theta only, then ellipse will remain ellipse only, because Cartesian to polar transformation does not change the shape of the region. But some special transformations are there which we can use for the scaling purpose. So these will scale down and it will convert the ellipse to the circle now. So we are interested in the region in a polar form only. So we'll draw a circle r equal to 1. So this is the r equal to 1. So if you draw a circle, if I say this is r equal to 1. So that is the entire circle, r is equal to 1. But we require first quadrant. First quadrant of ellipse will map to the first quadrant of circle. So the region of integration is only the first quadrant of a circle because we are given a first quadrant of ellipse. The strip is always along a radial because we are in polar, but a special polar transformation of ellipse. So r equal to 0 to r equal to 1. So I will say here the double integral, this double integral in a polar form with that special transformation will become value of y is a br sine theta. This is the value of y. Dx dy is abr dr d theta, and the limits of r is a 0 to 1 and limit of a theta 0 to pi by 2. That's one. Now the integration is only left. Any doubt there? Yes, 149. Uh, 120, it is not arc sine theta or okay, AR cos theta. Okay, sorry. You may...
Sir,
Yes.
if it was if the values of A and B were different, then
Whatever, it can be anything. No, we are written in general only. Suppose instead of A, there is like a denominator is a 4 and 9. Then you can say x is equal to 2 cos theta, 2r cos theta, and y equal to 3r sin theta. That is particular.
okay,
What
sir,
is
but R
no,
will be 1.
r will be always 1. You check because what happens that ellipse is not remaining ellipse only. You substitute values here. You will get r equal to 1 only.
Okay, sir, okay.
We find the image of that ellipse. Image of ellipse is the circle of radius 1 always. Yes. 149, is there a doubt?
No, sir. No, sir.
Oh, good. So what is the integration 149 then?
Yes, sir. So ab square will be constant. Ab square sine theta will be constant.
Okay, ab square will be a constant.
Sine theta
Sine theta,
also.
okay, you are integrating with r, then
Respect to
sine
r.
theta. Okay. So
Then it will be
0 to pi by 2, I will as it is, sine theta as it is.
okay.
And then
R cube by 3. R cube by 3.
r cube by 3, 0 to 1,
1.
d theta.
Yes, sir.
Okay, so this is a b square by 3 is a constant. The integration of sine theta.
Minus cos theta. Yes, sir.
Cos
Will be
pi
1.
by 2. 0. Cos pi by 2. Cos 0 is 1, na? Lower limit of the minus sign. So final
Plus
answer
1.
is
Yes, sir.
ab square by 3. So whenever we do the double integration on an ellipse, okay, just like whenever we do the double integration on circle, we transform it Cartesian to polar only. But whenever we have to do it on the ellipse, we transform to the special transformation of ellipse. Not by simple polar transformation, it is by the special polar transformation. These are special polar transformation made for the ellipse only, which always deform the ellipse to the circle of radius 1. In the last two sessions, we already seen the region of integration not necessarily remains same. We seen the triangular region become the square and all that thing. So that is for general transformation. But here, only there is one transformation, simple Cartesian to polar, which converts same region, means that it will not change the shape of a region. Any doubt, anyone?
No, sir.
Okay, good.
No.
So one more example. Now you'll observe we have to evaluate this complicated. It looks complicated actually, but not so difficult. Where R is the region enclosed by the ellipse in the first quadrant. Remaining part is the same. Only there is one simple thing that we can do it so that we can use a proper substitution. Yes, what can you can observe here? Or First of all, it is on ellipse. So transformation, we use that one. X equal to AR cos theta. Y is equal to BR sin theta. By this transformation, x square plus y square upon, x square upon y square, or x square upon a square plus y square upon b square is equal to 1 becomes r square is equal to 1, and that is r equal to 1. So that we seen in the last example also. Yes, anyone? What do you observe here for simplification?
So we can divide by a square, b square.
Very good. And that's the main
AB
option.
will be outside, sir.
So it is 1. It will not outside. It get cancelled.
Cancel out, sir.
Okay, cancel out. Correct. So it is 1 minus x square upon a square plus y square upon b square. So numerator have the minus sign, but the denominator will have plus sign. And that dx dy will be as it is. This is the given double integral. Now by this transformation, I want the simplified values. Tell me, what will become the integral now? 130. Yes.
1 minus r square upon 1 plus r square.
Very good. 1 minus r square upon 1 plus r square. And what is the value of dx dy?
ABR dr d theta.
ABR dr d theta. Is that you said? ABR. This is the value of dx dy. ABR dr d. What about the limits of r and theta?
0 to 1.
0 to 1 and 0 to pi by 2.
Correct. Again, a first quadrant is there. So it's a 0 to 1 and 0 to pi by 2. That's one. Now the task is only to integrate this. Now the integral becomes a simple
Sir,
yeah.
X square by a square plus y square by b square is equal to r square.
Correct.
How, sir?
Here is only simplified. No, this is only r square we written here.
Yes.
If you are not still getting, you replace this x and y there. These are values of x and y. Replace it here, and you check what is the value you are getting.
Okay, sir.
How to integrate now?
So we can put r square equals to t.
R square equal to t. Okay, that is one of the substitution.
And then you can factorize.
Okay, multiple ways are there. So choice is yours. So substitution method will work. So the best transformation, I will say, I will take this 1 plus r square equal to t square also. Okay. And then you will get value of r dr also. Your choice. You can do it any of the transformation. So let I proceed here. I will do the substitution like this. So choice is yours. You can take only r square equal to t or r square equal to t square. It doesn't matter. So I will take just a minute. 1 plus r square is equal to t square. So value of r square become t square minus 1. We want 1 minus r square again. So we'll do that. So first of all, 2r dr is equal to 2t dt. So r dr is a t dt only. Value of r dr is a t dt there directly. So the integral become 0 to pi by 2 as it is, square root of, now denominator is a t because we replace 1 plus r square is t. What is 1 minus r square? 1 minus r square is 1 minus t square minus 1. So this become 2 minus t square. So 2 minus t square. Actually, okay. So 2 minus t square upon t square is coming.
So denominator will be t square, no?
Correct, correct. It is a 2 minus t square divided by t square. Good. And this is a AB t dt d theta. But still,
Sir, t will be
Further
cancelled
t
out
will be
easily.
cancelled out, sir. It will be root 2 minus
correct.
t square, sir. A
The
square minus x
denominator
square
t
formula.
square will be cancelled, the numerator t1, sir.
So it is a 0 to pi by 2 root of 2 minus t square AB dt d theta. Okay, inner limits, I missed that actually. So one integral I missed there. That should be there. Integral, and it will have limit also. Remember, when r is a 0, what is a t? T is 1, na?
1. Yes, sir.
And when r is 1, t is
Root 2.
root 2.
Root
That's
2,
correct.
sir.
So this is root 2 is there. So 1 to root 2. Still, the integral is not completed. There are many more things missing. That is to integrate root of 2 minus t square.
Sir, we can use the standard formula a square minus
Under
t.
root a square minus x
Yes,
square.
sir. Under
Yes,
root
a
a
square
square
minus
minus
x
x
square.
square.
Correct.
सर ये रूट टू कैसे हुआ था सर एक बार बताइए.
You will observe what is upper limit. R is 1, na? Replace r by 1 here. So 1 plus 1, 2 is a t square. So what is t is a root t, na? Root
Okay
2.
sir. Okay sir. Thank you.
Yes, sir. Now here you can use the integration of root of a square minus x square as that x by 2 or t by 2 into root of 2 minus t square plus 2 by 2 sine inverse of t by root 2 something. You can check it and you can proceed there. Can we finish it, or you are going to do the remaining steps?
So we will do this.
We will do, sir.
Okay.
We will do, sir.
Okay then. So that about this question. One more question is on the ellipse there. You do it your own. That's for the today. I'm not going to, because now it's a repeated case only. Okay. So I will say that is the end of our type 5 example. Type 5 examples. So next session we'll see application to find the area. Okay.
Sir,
Yes.
so can you please do it again by taking r square is equals to t?
Pardon?
Sir, can you please do it again, this question, sir, by taking r square is equals to t?
No, that is your way, na? You should do it. Calculations, you should do it your own. Huh?